All right, this last section, what we're going to be looking at is looking at the ratio between uh, area and volume of figures. So like the surface area, or just say area of one side, and then looking at it as it relates to the volume of the figure. And we're also going to be looking at, okay, if the side length is this and the other length is this, what's the ratio for the volume? But first, a little detour from that, and the last real volume thing that we're going to be looking into is called conical frustum. And what this is, it's kind of like if you take a cone or if you take some sort of pyramid and you cut off the top of it and you just want the bottom half of it. How do you find the area of that? And it's kind of like doing the area of a trapezoid, but we're going to have to take the volume of it. And so to do that, your volume is equal to 1/3 times the height of it, so how high it is. That whole thing is multiplied by the area of the top, of the area of one part of the top or the bottom, plus the area of the other one, plus the square root of the sum of the two, or the product of the two multiplied together. So what's happening is that you're going to go 1/3 times the height, and then multiply that by this area, plus this area, plus the geometric mean of these two. So you're going to multiply them together and then take the square root of them. And that's kind of what it is. So here's an example of what it would be. So if we had a top is 5, the bottom is 8, and the height is 10, and it's circles, we want to find the volume of it. Well, our B1 will be pi 5 squared. Our B2 would be pi 8 squared. And then underneath the radical would be pi squared times 5 squared times 8 squared. And so what we have here is that when we multiply all these together and everything, we end up getting, and then we put in a 10 here. We end up getting about 10/3 times 25 pi plus 64 pi plus looks like that's going to be about 40 pi, I believe. And then you're going to add all these up, get you about what's that going to get you? That's going to get you about a 129 pi. Divide that by 3. Divide that by 3, getting you 10 times 43 pi, which gets you about 430 pi, which comes up to approximately that number. Okay. Inches cubed. So again, it's just kind of plugging in. It's just something different. It's another shape. You won't have to memorize this per se, but I mean, it's another object that you're able to find what the volume is, and again, it's kind of cool. Okay, so the next part, what we're going to be looking at is we want to find the ratio. So with these two figures, what is the ratio of the perimeters of them? Well, the perimeter of the first one is 25, so it'd be 25 to 20, not 25. 20 to 7 times 4 is 28, which then can be reduced down to 5 to 7. Okay, so 5 to 7 is the ratio for the perimeters. Okay, which, if you notice, is just the sides. Well, what's the ratio for the areas? Well, our areas here, we've got 25 and 49. Can we reduce those in any way? No, not really. So we're left with a 25 to 49 ratio for the areas. And that's what we kind of have. And what do you see as the connection between these two? Well, the connection between these two is that the perimeter is just the sides, and the area is the square of the perimeter. 25 is 5 squared, and 49 is 7 squared. So what we've kind of done is we've just squared them. So if our perimeter were to be, let's say, AB of some figure, then the area of the figures, if they're similar, of course, they're similar, the area would be the ratio of A squared to B squared. So you just square whatever it is. No matter what the shape is, if they are similar, then it's going to be just the square of the two. Okay. And then for the volume, what do you think the volume is going to be? Well, if the area was squared, the volume is just going to be cubed. And so the volume would be whatever the side cubed to the other side cubed. Okay. So you just cube the number and then get your ratio. And you can't really reduce it. If you've reduced the first one all the way down, you can't reduce any of the other ones down. So let's look at this. So we've got the volumes of two solids are 128 and 250. Okay. The surface area for the larger one was 250. So now we want to know what's the surface area of the smaller. And so some people will just jump and say, oh, well, it's going to be 128 because it's the same. Well, no, because remember, this is the volume, which means this is A and B cubed. Okay. Now, what we can do here is that we can either take the cube root of both of these, or we can see if we can reduce and maybe we can get a nice number. So let's divide both of these in half. So we're going to divide both of these in half. 128 divided in half is 64, and the next one is 125. Okay. So now let's take the cube root of both of these. If we were to take the cube root of both of these, so what number multiplied 3 times together gets you 64? That would be 4, and the other one would be 5. Okay. Now this is your A and B, so that's A over B. Well, what would the ratio be for the area of it? Well, we just square both of these, so it would be 25 over 16. Okay, that should be the area. So now we've got a similarity, okay, a similarity ratio, in which now we just cross multiply, divide, or see what it is, and we find out that x has to be about 160. Okay, and as you see, the areas are different than the volumes, even though the volumes are the same, because of the ratio between the two are different. The area ratio squared, the volume is cubed. And just like the sides would just be A over B. Okay. So what you have to do is you have to find what your AB would be, and then you would set up a similarity ratio to find what it is. Okay. Okay, so here's what I want you to do. The volumes of 2 cubes. Okay, so cubes, so they're identical polyhedron. 2 cubes. One is 8 cubic units, the other one's 125 cubic units. Okay. What I want you to do is I want you to find the ratio of the two sides. So basically, what's the ratio of the two sides of the figures? Okay. So use the properties of volume, the volume ratio, and then the area ratio, and then down to perimeter ratio. Find what they are, and then just set up the ratio for the sides of these two figures.